In this section, we'll explore logging in to a local computer. From a graphical user interface, we would be presented with the users on the system that we can log in with. Any user whose credentials you have, you can access when you have direct access to the machine itself. Here, I'll log in as the demo user. Supplying the password for this user should allow access to the graphical user interface. Once the graphical interface loads, and we have access to all the applications within the operating system, we can browse into Activities and launch the piece of software called Terminal. In a Red Hat environment, this will launch us into a bash shell. From here, we can begin supplying commands, their options, and arguments to control our environment. When you're logged in this fashion, you're utilizing the Linux machine's physical console. Once logged in, the physical console supports many virtual consoles, each running a separate terminal. Every virtual console supports an independent login session. If you were to be logged in with multiple users or switch users during your login, you would create and switch to a separate virtual console. You can switch between these consoles using the Control and Alt keys plus one of the function keys F1 through F6. Most of these virtual consoles run a terminal providing only a text login prompt, and if you enter proper credentials in the form of a username and password, you'll be able to access a shell prompt. Computers that have graphical login prompts will only be available in the latter virtual consoles, namely Virtual Consoles 4, 5, and 6 in typical environments. You'll access those virtual consoles by using a combination of the Control and Alt keys and the corresponding function key, F4, F5, and F6. As we just saw from within our graphical environment, we can utilize the terminal command to then access a shell prompt. Many systems, however, run without a keyboard or monitor attached and may not even install a graphical user environment. Systems configured in this way are known as headless servers. A headless server would not have available to you the physical console to log into and would require remote access. We'll take a look in the next section of how to access headless servers via remote or network-based logins. We learned that many Linux systems can be configured as headless servers, or that they don't have direct physical access to the machines or keyboards and monitors connected to those systems. In these configurations, we need to understand how to access those machines over the network. Within Linux, the most common way to get a remote shell access to one of these systems is by using the application SSH, or the Secure Shell. The Secure Shell application encrypts your connection from wherever you're located to the remote system to allow you to pass traffic safely and securely and access those remote systems over the network. Here you can see an example of a sample SSH command. Dissecting this command a bit further, it requires a few pieces to form an argument. First, we'll invoke the SSH command itself. In order to describe to SSH where we would like to connect, we'll need to supply two main components. The first is the remote user you wish to use when accessing a remote host. The remote host represents the machine you're logging into, and the remote user represents the set of credentials you're going to use when accessing that machine. Once you've supplied this argument and press enter, the password for the remote user will then be requested. An important thing to understand is that when you type this password, your characters will neither show on the screen nor will the cursor move. This can be confusing for first-time users, as they seem to think that their keyboard is simply not inputting the characters. It is for your security that the number of characters that you're entering is not displayed on the screen, nor is the cursor going to move. Simply type the proper credential password and press enter. Let's have a look at an example of this from a terminal itself. I have in my environment a server A, so I'll try to connect to server A using my demo user. If properly configured, this should lead to a prompt that prompts me for my demo user's account and provide access to that system if the user exists. The command we'll use is SSH, and then we'll declare our user of demo at the server we wish to connect to, and I have a system called server A. If I press enter, it will prompt me for my demo user's name. After being prompted for the password and supplying the correct information, I can see that I now access server A. If it's your first time for this user to connect to the system, you should be presented with a yes or no prompt that explains that you'll be accessing the system for the first time. If you wish to proceed, type yes and hit enter. This will handshake and add a fingerprint so that the system is aware that it is familiar with your user and has now been accessed for the first time. Depending on how systems are configured, additional messages may be displayed. Your results may vary depending on the type of environment you have configured. In this section, we'll learn how to log out of connections we've established. It's important to know how to break the connections you've established using SSH. It's very easy to do so, and you have two main options. One way to do so is to simply type the command exit, which instructs the terminal to sever the connection. An alternative to the exit command is the shortcut Ctrl+D. Let's take a look back in our terminal and see how we sever that connection. Here you can see we're still logged in as the demo user on our Server A system. By typing exit, the connection to Server A is closed and we're returned to our workstation system. That concludes our section on logging out. I'll see you in the next video where we look into some hands-on exercises using these new skills.